Hi everyone, welcome to the first video in Unit 6, Operations on Functions. You can see the objectives listed here. We're going to review the operations on functions and work with composition functions and their domains. This part right here is a little bit fuzzy. I made it a little smaller just so we could see it. But there are 4 basic operations on functions, and these should be pretty self-explanatory. I think the hardest thing about it, if there's anything hard at all, is the function notation. So I wanted you to take a look right here at the function notation, especially for, say, addition. These two things are equivalent, and all it means is take two functions and add them together. You know, it's not that hard. Subtraction, you're going to subtract the second one. The hardest thing about that is that you're going to want to distribute the negative to the second function. Multiplication and division. Now, division has one additional caveat to it. Remember that you cannot divide by 0. So whatever the function is in the denominator, it cannot equal 0, so you would solve for the x value that would make that 0. And right here you can see that 2x over negative x plus 5, it doesn't matter what the x is in the numerator, but it does in the denominator. And so that would limit the domain. So you can see here in example 1 that if we wanted to add f and g together, f is x squared minus 4. And then g is 2x plus 1, and so we're just going to add those together by combining like terms, and we're going to end up with something that looks like that. Same thing for the subtraction of two functions. We would have x squared minus 4, which is f, minus, but this time I'm going to put g in parentheses because we want to distribute the negative. So this will be x squared minus 4 minus 2x minus 1. And you can see quite clearly that you get a different polynomial when you subtract. So the other two functions were to multiply and divide, and it's just exactly what it looks like. So you would take the f function, multiply it times the g function. And I'm not going to take the time to multiply that out right now, but you know, usually what we do in class is we use a box to do that. x4, and then we do this. And that's just to stay organized. Now division is a little bit different, so I would put x squared minus 7x plus 2 over the g function, which is x plus 4. And x plus 4 is not a factor of x squared minus 7x plus 2. But remember that we cannot divide by 0. So we have to limit the domain. So the domain on this one here for this, the multiplication of functions, is just all reals. But here it's all reals except where the denominator equals 0. So, and I have this symbol not equal to because x cannot equal negative 4. And if you write that in interval notation, that would be negative infinity to negative 4. And then like there's a gap there, 4 to infinity. When you talk about composition functions, it has funny notation, but it's really not that difficult. For instance, and I've got the example here, but for instance, if I have f of x is equal to 2x plus 1, and I want to know what f of 0 is, then I would put in a 0 for x, right? And this would just be 1. Or if I wanted to put a b in, then that means a function where its variable is a b. Well, I could get a little fancier. I could say 2b. And then everywhere there is a variable, I would put in a 2b. So a composition function says, I'm going to take whatever g of x, that function, and I'm going to put it in for the x in the f function. So you've got an inner function, and then you've got the outer. So what that looks like algebraically is f of g of x is f of g of x. It's got that little O between it. It's not really an O. People call it fog because it's funny, but it's really just a big circle, or tiny circle really, and it's f of g of x. And so these two notations mean the same thing. So if I have g of f of x, that would just be written this way. Okay, so what that means over here is says, example 4, for each pair of functions, find f of g of x and g of f of x if they exist. State the domain. I'm not going to state the range, but I'm going to state the domain for each composed function. For each composed function. Okay. All right, so f of g of x looks like this. F of g of x. Well, what is g of x? Well, g of x is 4a. So we're going to take the f function, and everywhere there's a variable, I'm going to put the parentheses, I'm going to put 4a in there, and this is going to be aa minus 5. And the domain of this would be all reals because it's just a line. If I do g of f of x, right, then I'm going to do, that means the same thing as g, and then f of x goes inside, so 2a minus 5. So what is g of x? Well, it's 4, parentheses, 2a minus 5, so that's 8a minus 20, once again a line, so this is infinity. So this screen had a little bit of problems, so pardon, I had to do a little bit of editing, and I still haven't completely edited it because there's still a weird word on there, but this time we're given some ordered pairs, and we're asked to find the composition function. So say, for instance, we want to find f of g of x, all right? So remember there's an inner function and then an outer function, right? And so where you begin is the innermost with the x, but it's not the x in the f, it's the x in the g. So I come over here, and the first f, and I'm going to keep track here, this is x, and then this is f of g of x. So I'm just going to keep track of my composite here. So my first x is 7, and g of x, g of the 7 would be 0. So this would turn out to be f of 0. Well, what is f of 0? So I would jump over here to f, I would find where the x is 0, and I would write -1. Okay, so let's do this again with the next set of points. So the x is -1. -1 goes to 7. I come over here to, I do this one. I say -1 goes to 7. I come over to the f function, and I find where x is 7 and write the y, which is 7. All right? Then I do the third point, right? 4, and that's what I'm going to write here, is 4. Then I'm going to say 4 goes to 9, 9 goes to 4. And then my last one is this 8, 2, right? So I'm going to write 8. 8 goes to 2, and then I come over here, 2 goes to 6. So it does exist for each one of those points. This is the composite function. All right, so what if we want to do g of f of x? All right, so I'm going to make another table, and this is x, and this is g of f of x. All right, so the innermost on this time is the x in the f function, and that starts with 2. So I say 2 goes to 6, but 6 does not exist over here, so this does not exist. Sometimes they'll write D and E for does not exist. So then we do this one. This is 9. 9 goes to 4, 4 goes to 9. This third point, 7, goes to 7, and 7 goes to 0. And then on the last one, 0 goes to -1, -1 goes to 7. So it does exist on the last 3, but it does not list on this one. And then the domain and range, the domain for the new function would be just the x values, right, these, and then the y, that would be the range if you were going to find it. So it's kind of a pattern. If you can think about, all this is just substitution. I start with x, I substitute it to get f of x. F of x now is the x in the g function. And you could do this on and on and on. If you had f of g of f of x, well, you start with that x. So there are all kinds of story problems, all kinds of real-life applications where composition functions are used, but none more than when you're taking discounts on items. Everything from cars to fabric to anything. So here's one that says Best Buy offers both an in-store $35 rebate and a 15% discount on a digital camera that normally sells for $300. Which provides the better price? Taking the discount before the rebate or taking the discount after the rebate? So if we work this out by hand, we have two possibilities. We have before and we have after, right? So if I take the rebate before, then before the 15% discount, then I'm going to subtract this off, and I'm going to have $265. I'm going to multiply that times 0.85, not 15%. 15% is what you take off. So if you take off 15%, then how much does the item cost? Well, 85%, and that's 0.85. So hopefully I can do this. 25, 2, 3, 13, 2, 5, 21. That's going to be 52.522. So the final cost of the digital camera will be $225.25 if I take the rebate before. If I take the rebate after, then I would take $300 times 0.85, so 0015, 0024. So that's going to be $255 less the discount, the rebate, which is $35, which is going to be $220. All right? So if I write this as a function, right, the f of x function would be the amount of the price minus $35. The other function would be the price times 0.85, right? So which is which? Well, if I do the rebate first, right? If I do the rebate first, that would be this one. This would be g of f of x, right? Because I would take the rebate first and then the 85%. And after, this would be f of g of x, because I would take the 85% first, and then, or the 15% discount, and then I would apply the rebate. So that's how that goes. So this is a good place to end this video. I hope you took notes. I hope you took note of some of the questions that have come up during this video, and I hope that you will ask them when you come to class. So I will see you then.